Okay, can never be same. What the point other they are saying? If in any case, what they are saying, if any case, three quantum number are same. Three quantum number are same. Quantum number are same. Then fourth must be different. Okay. Fourth must be different. Are you sure? Okay. Now go for the titanium. Okay. What they are saying? Explain. Question they are saying. Explain pauli exclusion principle. Which one? Pauli exclusion. Exclusion principle. Principle for last two electron of titanium. Last two electron of titanium. Ti. Doing. So no doing.
Titanium, sir, atomic number of titanium is
22. 22.
two, two, four, four, 6, 10. So this should not be there.
2 to 3 is 2.
2, 5, 0, 10, 12.
Take time. Don't be, hurry up. Just take time, little bit think on it. It will automatically come.
So this I'm doing just after.
Yeah, but this is not the 22. Now you count the electron. It is 20. Up to here is 20.
Yes,
not.
so this one last calculation. 4s2.
After 4s2, which will come?
4s2. 4s2 3d.
3d2. Thank you. Correct.
Now in case of 3d2, we are having the electrons like d means sp d. So this is 0, minus 1, minus 2, plus 1, plus 2. So for the last two electrons, and this is plus half. Spin quantum number is plus half in both cases. Therefore, for 21st electron, we are having n equal to 3, n equal to d means 2, m equal to minus 2, x equal to plus half. 22nd electron, n equal to 3, n equal to 2, m equal to minus 1, s equal to plus half. Now, so we can see that this one is different.
So hence proved, right?
Yes, sir.
Okay. So many things you already studied well. So these things are there. What? Okay. Now come back to the hydro. Okay, these things you know, this portion already you know. Now let us go with the hydrogen spectrum. Hydrogen spectrum. What is hydrogen spectrum? Now again, I am coming back. Okay, because I thought of that we should study the easiest things first, then we proceed in the same sequence. So now hydrogen spectrum. Can you tell me please hydrogen spectrum?
The hydrogen spectrum, so spectrum means that we are having a band of lights of different colors. So this band depends upon the impression taken on the spectrometer by the various types of radiation emitted by the electron when it jumps from the various energy levels. Like we are having some series like here, like Lyman series, Balmer series, Passion series, and
Okay.
this series that
How?
we are having two types of spectrum. One is a continuous spectrum, another is non-continuous spectrum. According to the non-continuous spectrum, the different elements within it will be having the will be continued from like they will not be having any differentiation as we see in a rainbow. But in case of non-continuous ones, then we will find some of these like light bands. Then we will again find a dark one. Then we will find light bands. Then we will find dark one. This type of thing will occur.
What is the discrete spectrum then?
Sir, discrete spectrum. Sir, I can.
Discrete is the same. Discrete spectrum is the same. What you are telling, that is non-continuous spectrum is also known as discrete spectrum. Okay. Why this is coming? Why this is coming? The discrete spectrum. Hydrogen spectrum is the line spectrum or discrete spectrum?
The hydrogen spectrum is
Continuous or non-continuous? That you tell me. Continuous.
Non-continuous.
Why
Sir,
it is
because
not?
sir, when we are shining, when we are having some kind of radiation, then we are passing it through some certain kind of material. Then, sir, some of the radiation will be absorbed inside, and sir, the rest will go. Sir, when we are forming the spectrum on the spectrometer, sir, this part will come. Again, this part which is observed is not coming. Again, this part which is not observed is coming. This type of this is forming the light bands, and these are the places where darkness is.
Excellently, you are saying. So you are saying that is hydrogen spectrum is non-continuous spectrum. Yes, you know.
Yes, sir.
Okay, that is a correct one. But how you are saying this type of the option will be there? How can you say the hydrogen spectrum is non-continuous spectrum? Okay, the question is there. How can you say the hydrogen spectrum is non-continuous? Okay, these things you keep in mind. That is how this spectrum now. This spectrum. Let us see. Okay, you are saying that is correctly. So here you are saying this way. So when electron either absorb the energy or the lose energy. Okay.
Sir, when it will absorb the energy, suppose this is an electron, it will absorb energy, then it will go to here. So that means radiation will be absorbed. And if it is coming from here to here, that means this is losing the energy. That energy is coming out in form of radiation.
Okay, the radiation is what is the radiation? What the radiation?
The radiation can be in the form of light, like visible ray, infrared ray, ultraviolet.
That is okay. Then what will be the electromagnetic radiation? What is electromagnetic wave then? I'm just putting the question. Kindly don't think otherwise. Okay, you may think sir is warmly asking, challenging me, argumenting, huh? No, not like that. Okay, just I'm just asking, that is how you have connected the concept. That is aim is the. Then what is the electromagnetic wave? Electromagnetic wave. It is there in your syllabus. What is electromagnetic wave? EM wave. EM wave. Yes or no? Just to recall it. See, two terms are there, no? Nothing to
Electromagnetic waves will be like there will be waves of this form, and they will be having two They will be there. They
This
will
is
be
the
having
normal wave. This is the normal wave. This normal
normal
wave.
wave only. So
Uh,
they will be having some wavelength and some frequency also they will be having,
hmm.
and they go perpendicular. They go perpendicular in the direction of their propagation. Like if this is the direction of their propagation, they will go this side. And another thing is there we can divide this into two components.
Hmm.
So this one.
Hmm. Hmm. Hmm.
So here the electric wave will go in one direction, and this magnetic wave will go in another direction.
Hmm.
Sir, both are going in the same direction of propagation only, but sir, they are going mutually perpendicular to each other.
Thank you very much. But how these waves formed? How this wave formed? Which kind of particle generating this wave?
Sir, this subatomic particle only generating this wave by absorbing and
Not only subatomic particle, not only subatomic particle.
electron. Sir, electron
The,
only, sir, absorbing and
Hmm.
emitting the energy they are
Hmm.
forming.
Hmm. The concept. This is the when you will study the Heisenberg principle, na, then you will find the more accurately the particle.
Yes, yes. Heisenberg principle saying that we cannot find the both the position of the electron as well as the velocity or momentum of the electron with the same accuracy. If one is certain, then the another would be uncertain.
Very good, very good. And one is also de Broglie equation also is there. What is de Broglie equation then?
So, de Broglie equation.
Okay, no problem. So what the point is there, any moving particle, moving charge particle, what the concept is there, moving charge particle, moving charged particle, moving charge particle. Moving means that is, they are saying any oscillating charge particle. Moving word is common word. The oscillating charge particle. They generate the waves. And the wave is having the two component, that is electrical component and magnetic component. And in the direction of propagation, they are the perpendicular to the each other. That is what the definition was the correct. There is no problem in the definition. But what you said, that is the produced by the moving charge particle. Now, what can you say about the electron? It is the charged particle.
Yes, sir, and it is moving also,
It
oscillating.
moving. So this type of particle, whatever the particle will be, they will be in the form of what? That is electromagnetic wave. Now, how can you say they are the perpendicular if suppose it is moving like that? How will say that they are the perpendicular?
Sir, because they are moving in two different planes. So, sir, if we make
Uh,
one like this according to this one, and
uh,
another would be like this.
uh.
Sir, the angle between these planes should be 90 degrees.
Okay, thank you very much. Without that one also you can say here it can be the 90-degree. You only said mutually perpendicular. Yes, yeah, no.
Yes, sir, mutually perpendicular.
So
Mutually
anywhere,
perpendicular as well as perpendicular to the direction of propagation.
that is okay. So this is this is the electromagnetic wave. Now, so whatever the hydrogen spectrum we got, that is also the type of the electromagnetic wave only. Now go back. Here there are the 5-6 series obtained. Okay, 5-6 series. What we need to know, this series energy. We have to find out the energy, and then we need to find out the wavelength. Then we will need to find out the wave number. This is all. Suppose, Sanoy, please wait a moment. Suppose
Yes.
electron will fall. In any case, electron is falling. It means it is losing the energy, right? It means obviously it is losing the energy. Then only it will fall, no? Yes or no? Yes or no? Are you listening?
Yes, sir.
Okay. So suppose from the any higher state to the ground state, any higher state to the ground state, what the series is going to obtain? Yes.
Sir, that depends upon the n value.
So tell me now, tell me. It is they are saying this is the infinite to the n is equal to 1. Then what will be there?
The Lyman series.
This will be Lyman series. Which region it will be there?
IR.
Lyman series IR. Okay. And what about this one? If they are going in the second orbit?
So Lyman, then this would be Balmer. Balmer is visible.
Visible region. Then next one will be there.
a passion.
Which region?
The passion is the UV region. This should be bracket. So bracket is also UV only. And
Then
then we are
after
having fund.
P1.
This is also
Hmm. Okay, that is good. One more things. How many lines is going to form? How you will calculate these lines? How will you calculate this number of lines? Number of spectral line, how can you calculate?
sir. Sir, we are having, suppose this is n equal to 4.
Hmm.
Now n equal to 4. This is 3. This is 2. This is 1.
Hmm.
First will come n equal to 4 to 1. Second will n equal to 4, 3, 2, 1. Sir, first will come 4 to 1, 4 to 2,
Uh,
4 to 3. Sir, it
uh,
would be the above the higher n minus 1.
uh, hmm.
So like here in this case, we are having 4 minus 1 equal to 3 lines.
3 lines. In case of Balmer, in
Sir,
case of
Balmer also, sir, we are having Balmer only, sir, we are having 3 lines.
Lyman,
Lyman 4 lines.
how?
Sir,
Which?
like this is the Lyman series. We are having from infinity to here, then we will be having infinity lines only. But sir, if we are having Balmer series, Balmer series is in 1, 2, 3, 4, 5. 5 to 1. So, sir,
Okay, sir,
then
no. Thank you very much. You are telling the descriptive one. Direct calculation you are not telling. Actually, I
sir, I do
was.
not know the formula if it exists, sir. I don't know.
Okay. Number of spectral lines. Suppose number of spectral line. Okay. So how we calculate? Number of spectral line. So that is n2 minus n1. Then again in another bracket n2 minus n1 plus 1 divided by 2. This formula is used for the any of the lines, any of the spectral
And this
line.
would there would be plus or into.
Where? In the bracket there is the into n2 minus n1 plus 1. Here you are asking, I think. Here is the into
Yes,
is
sir.
there. Here is into. Okay. So fifth orbit to first orbit. Fifth orbit to first orbit.
5 minus 1, 5 minus 1 into 5 minus 1 plus 1 divided by 2, 20 by 2, 10.
10. Okay. So this way we need to calculate. Okay. For any lines you can calculate. Is it okay? Is it okay? You need to
Yes.
memorize. It is the simple one. N2 minus N1 again N2 minus N1 plus 1 divided by 2. It automatically get okay. Now, so you said that is when electron falls, when electron falling from the any energy orbit. So you said these loss of energy in the form of what? Loss of
This is the
energy.
electromagnetic radiation.
In the form of radiation, loss of energy. Loss of, because electron cannot stay in the higher energy orbit. Why it
Yes, sir.
cannot stay? Because higher energy orbit are the unstable condition. Greater the energy, greater the instability. So they will always try to be in the lower energy. So they will be there for the 10 power minus 6 second, very less time. Okay. So after that it has to fall. So loss of electron, loss of energy energy in the form of radiation. In the form of what they are saying, radiation. It will be in the form of radiation only. Getting my point? Loss of energy is in the form of radiation. Okay. Up now, then if they are the radiation, okay, if this is the radiation, so what is the energy? Energy.
It's
Energy.
equal to HU.
Oh no. Energy of radiation. Energy of radiation. When electron falls from A, N2 to N1, and B will be infinity to N1. Oh, which have high wavelength, which have highest wavelength. बताइए आप. अब एच म्यू से तो काम नहीं चलेगा आपका, एच म्यू से आप नहीं बता सकते इसको. प्लांक क्वांटम थियरी पढ़े हैं आप? प्लांक क्वांटम थियरी
सर उसी में ना ना h इक्वल टू एच
हाँ.
सी बाई
लेकिन इधर में देखिए ना, n2 - n1 भी है, उसको भी तो कंसीडर करना है भाई. सबकी
हाँ
सबकी एनर्जी बराबर तो नहीं होगी ना, एच न्यू के
हाँ सर
बराबर. हाँ, ये सबकी एनर्जी, सबकी फ्रीक्वेंसी भी बराबर नहीं होगी. देयर विल बी द सम लॉजिक. व्हाट इज द लॉ? हैव यू स्टडी द रेडबर्ग इक्वेशन?
नो
रेडबर्ग इक्वेशन नहीं पढ़े हैं?
फीडबैक
हाँ, ये these we can calculate with the help of Rydberg equation. E is equal to h mu is the simple, that is the.
actually मतलब I read this one sir a
हाँ
few days
हाँ.
back. I do not recall most of the
No
things.
no no, not a problem. Just I'm also teaching you in this way only. Just taking more and teaching less. Okay. So here's what is there. See, if you are calculating the E, है ना, E total. So energy. So you can give that is E2 minus delta E actually. Delta E is equal to E2 minus
तो
E1.
मैंने सुना
Okay, because energy gap, if I will talk about energy gap, this is the nucleus, this is the first one. So energy gap we studied also. Okay,
Free room? What time will be?
half an hour more.
Okay, actually, I got call from विवेकानंद
हाँ
बुला रहे हो.
हाँ
तो मैंने बोला कि सर तुरंत आऊँ, ऐसे कितने बजे तक आप बैठेंगे? तो बोले 12-1 बजे तक. तो बोले सर 12 o'clock आती हूँ बिकॉज आई हैव अ कोचिंग नाउ.
हाँ. Okay, okay. हाँ सुनो. So
sir
sorry ना.
actually I wanted to say something sir मेरा वो I had a class from 10 p.m. sir another one
Oh,
sir physics
oh,
only. Vimal sir told that he would be doing class after your sense.
oh, okay, okay. So 10 o'clock. Did you text to Bimal sir?
No sir not yet sir he told that I called him yesterday night only.
Okay. So no, what there, one point is there. Sometimes what is the, every teacher is having different way. Different way
Yes
means
yes.
different way of satisfaction, right?
Hmm.
Satisfaction in the same. If I am teaching, until or unless I will satisfied, I will try to do. Okay. So
Yes sir.
kindly, sometime I give more time because what is their teaching is not all about the doing duty. Okay. We have to
Hmm.
find the some satisfaction, some sort of satisfaction. Kindly do not tell that I am taking extra classes or
No
extra
no no
timing.
no.
Extra timing, extra. It is my personal way of teaching.
Yes sir yes. Yes.
Because see, everybody is not having the time. Everybody is
Hmm.
having different, so some days we study extra. Don't tell the extra date. Only the timing what you fixed, that is one day na. So whatever the
Yes.
extra, like this
Sir, one
Tuesday,
day, not 2 days. One day, another Wednesday also we are
but
having 1 hour.
we talk one day na. Tuesday to I am giving you na. Tuesday I am giving you na. But we talk one day. Tuesday is different. Tuesday I'm clearing your doubt. That is different.
Tuesday now Wednesday.
Wednesday. That is different na. That is what mutually we talk na. That I got free. That is why I'm taking. I got
Yes.
free. That is why taking. If I'm not free, how can I take? So
Yes.
don't tell these all things because sir is taking 2 days like that. Because sir is not having time. Getting my point? Hello, Sanu.
Yes. Yes, sir.
Sir is not having time. The Wednesday he is taking he is having many batches. I just stopped the one batch is 10th standard. That is why I got free.
No, no, okay, sir. You please come.
So like that. So okay.
Sir, how much time you please take the class? I do not have the problem.
Okay. So okay.
Sir, I
So
will
now,
adjust. I will adjust.
so you are going for the physics now.
Sir, you take the class until and unless you are satisfied. Sir, rest I will adjust.
No, okay, that is okay. What I'm saying, the now physics class is there 10 o'clock.
Yes, sir.
So can we off this now? I think 10 o'clock. It will be 10 o'clock only.
Sir, now it is 10 o'clock only, sir. That is
Ah.
what.
Okay,
Sir,
you.
if sir, if you need more time, sir, then I can arrange, sir. I will then request Bimal sir to like postpone it a bit.
Okay, but he may be waiting now. So what you do? Today you study the physics. Today you study the physics. Next class onward, next Sunday I will start to actually study. I went to Varanasi. So
Yes, sir.
returning back, it got 3 o'clock. That is why I could not take 8 o'clock. So next class, if I will take 8 o'clock, so you may have the penalty of time, right?
Yes, sir.
So we'll study the hydrogen spectrum properly, and we will do the Rydberg equation also, right?
Yes, sir.
Okay, Sana. Go and call to Bimal sir and take the class, right?
Yes, sir. Yes, sir.
Okay, bye.
Thanks.